This is question 6A of the practice exam. And this question here, you're given a current that is passed over a particular amount of time and told that you have a solution of copper sulfate, which breaks down into copper 2+, an aqueous solution, and 2 copper electrodes within your beaker, and you're passing this current between the electrodes. And what you want to find out in the end is the change in mass of these electrodes. You want to know, in both cases, how much copper was used and how much copper is generated. So what's really happening here, we always have a cathode and an anode, right? So at our cathode, if our cathode is made out of copper, cathode is the reduction. Put that in there to remind ourselves. So that's going to be copper reduction, which means that it's copper 2+ going to copper 0. And to balance that, you need to have 2 electrons, right? What's happening at the cathode? At the anode, where that's oxidation. So that's solid copper going to copper 2+ plus 2 electrons. So the question is wondering how much copper is generated, the cathode, and how much copper is lost from the anode in mass. So we want to find mass of copper for each of those. To find mass of copper, we need moles of copper. To find moles of copper, we need moles of electrons, and then we can use our balance equations to go up the chain. Now, we know that our charge is equal to IT. We can find out how many coulombs are passed. It's also equal to the number of electrons, or the moles of electrons, times Faraday's constant. Moles of electrons is what I want to find in this question. I have the charge, or the current, I have time, and I know Faraday's constant. So we're going to use Z equals IT over F. Just watch your units in this case. So our current is 2.68 amps, which is a coulomb per second. Time, you have to switch into seconds. Oh, and I already did that for you. It actually told you 1 hour. Right? So 3,600 seconds over Faraday's, which is in coulombs per mole electron. So you end up with 0.1 moles of electrons. Now going to the balanced chemical equation, our moles of copper is going to be equal to our 0.1 moles of electrons. And then we're using our stoichiometric ratio. It's 2 electrons for every 1 copper. We have 0.05 moles of copper. Then you can find your mass of copper using your moles times your molecular weight, which is 63.55. So you should get an answer of 3.18 grams. Now be specific in your answer though. So at the cathode, remember cathode is reduction. That means you're making solid copper. So that means you're going to have an increase in mass of 3.18 grams. And at the anode, that's where our copper is being oxidized. We're going to be losing solid copper. We're going to have a decrease in mass of 3.18 grams. That's the answer for that question.